Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over another combustion analysis type problem and where you are asked to find the empirical formula of an unknown compound. So let's get into this. So in this problem we're given an unknown compound that contains only carbon and nitrogen. Combustion of 0.9500 grams of this unknown compound results in the formation of 0.1411 grams of N2O, 0.1925 grams of NO, and some CO2 as the only products. Determine the empirical formula of the unknown compound. So, as you do with your combustion analysis type problems, you've got to figure out what the moles are of each element in the compound. So basically what you want to do is take the grams of the compounds that you produced from the combustion, convert that to moles of the elements that come from the compound, and then do your pseudo formula and go from there. So this problem is a little bit more difficult in that they're telling us that it's only carbon and nitrogen, but they're telling us that it forms two compounds that both have nitrogen in them and one compound that has carbon in it, CO2, but they don't tell us how much. So we got to find that out first. Okay, so let's start with what we do know. We know that all of the nitrogen that came from our unknown compound ended up in two different products. So that's going to be NO and N2O. So what we need to do is find the grams and the moles from that, the grams from each of those, and determine the total grams of the nitrogen from the original sample. So let's go ahead and do that first. So we're given 0.1411 grams of N2O, so we'll convert that. So 0.1410 grams of N2O. And we're going to take that and we're going to convert that to moles first. So we got to use the molar mass. And so the molar mass of N2O is 44,013. So 44.013 grams of N2O on the bottom, 1 mole of N2O on top. So grams of N2O are going to cancel out, leaving us moles of N2O. And now we want to convert this to moles of nitrogen using the mole ratio in the formula. For every 1 mole of N2O, that gives us 2 moles of nitrogen. So we're going to use that mole ratio to convert to moles. So 1 mole of N2O on the bottom, 2 moles of N on top. And now we're going to convert to mass of nitrogen using the molar mass of nitrogen. And it's 14.01 if I remember correctly. That's going to be, 14.007. I was close enough. So 1 mole of nitrogen on the bottom and 14.007 grams of nitrogen on the top. So moles cancel out here. Sorry, I forgot to cancel the moles of N2O, cancel out moles of N2O, and we're left with grams of N. So the grams, so this is going to give us the grams, multiply by everything on the top, divide by everything on the bottom, and that's going to give us the grams of nitrogen from N2O, which came from our original sample. And when we calculate that out, we get 0.0898, 0.0898, 09. Wait, let me double check that again. 89809, yep. 0.9 grams of nitrogen. And now we can do the same thing with NO. Do the exact same process to find the grams of nitrogen from our original compound that end up in NO during the combustion reaction. So we're going to take 0.1925 grams of NO. We're going to use the molar mass of NO to convert that to moles. And so that was 30.006. So 30.006 grams of NO on the bottom and 1 mole of NO on top. So grams of NO cancel out. Now we're going to use the mole ratio in our formula. So for every 1 mole of NO, it's 1 mole of nitrogen. So we're going to use that to convert to moles of nitrogen. 1 mole of NO goes on the top. 1 mole of N goes on, I said moles of NO on the bottom, moles of N go on top. So moles of NO are going to cancel out. And now I use, again, the molar mass of nitrogen to convert to grams. So it's going to be 1 mole of N on the bottom and 14.007 grams of N on top. Moles of N cancel out. And once again, multiply by everything on the top, divide by everything on the bottom, and I'll get the number of grams of nitrogen, which I get is, let's see here, 0.0898. Yes. So 0.0898, 60, I believe. 60. Let me double check that. A 0.89860. Yes. So this is going to be grams of nitrogen. And it's, if you look, it's like almost exactly the same number of grams. So it looks like it was divided evenly among the two substances. So now all I need to do is add these two together. So add those together. And I end up with 0.17966, 0.17966.9, I believe, 9669 grams of nitrogen total. So now I have the total grams of nitrogen. So I know that the original sample of my compound was 0.9500. So to get the mass of the carbon, because I know that my original compound is only made up of carbon and nitrogen. So I've got the total mass of my nitrogen. So all I need to do is subtract that from the total mass of my compound, and the leftover mass has to be due to the carbon. So let's do that. So I'm going to take 0.9500. I'm going to subtract 0.1796669 grams of nitrogen, and I'm going to end up with 0.7703, 0.7703, 7.731. So 31 grams of carbon. So this is the mass of carbon in my original sample. So now that I have the grams of carbon and the grams of nitrogen in my original sample, I can now use the molar masses of carbon and nitrogen to convert to moles. Why do I want to convert these to moles? This will be the mole ratio that I will have in my formula. So I can build up my pseudo formula first and then get to the empirical formula. So let's do that. So next I'm going to take the 0.770331 grams of carbon. I'm going to use the molar mass of carbon, 12.011 grams of carbon on the bottom, 1 mole of carbon on top, grams of carbon cancel out. And so the moles of carbon that I calculate is going to be equal to 0.0641, let me double check that, 0.0641, 0.64135. So 35 moles, and that's moles of carbon. And then I can do the same thing with the nitrogen here. So I'm going to have 0.179669 grams of nitrogen over 1. And then I'm going to use the molar mass of nitrogen. So 14.007 grams of nitrogen on the bottom, 1 mole of nitrogen on top. So grams of nitrogen cancel out. Now I have moles. So when I calculate the number of moles of nitrogen, I get, let's see, moles of nitrogen. Where are you? It's going to be 0.012, 0.012 827 moles of nitrogen. Now that I have the moles of nitrogen that come from my original sample, now I can put this in a pseudo formula and then simplify it to get to my empirical formula. Well, how do you do that? Well, since these are moles, and when we write our formula, the subscripts are the moles, but it's in a mole ratio. So what I can do is I can take the moles and write them as subscripts in my formula and start with that. So let's go ahead and do that. So I have carbon, and then I'm going to rewrite this as a subscript. So 0.06415. And then I have nitrogen. I'm going to rewrite this number as a subscript, 0.012, 0.012827. Now, you don't need to write all of these digits. I'm just being, I'm doing too much. You could keep 3 or 4, but you just want to make sure you have enough that you're not rounding too much, because you want to make sure you're getting a nice ratio here. Well, so if I'm going to use these as subscripts, remember the subscripts is the simplest whole number ratio. Well, how do I get a whole number ratio out of these? Well, you do it by dividing by the smallest one. So I'm going to divide. I have 0.064135, and here I have 0.012. So this is smaller than this. So I'm going to divide both of these by the smallest one, 0.012827. Divide this by 0.012827. Obviously, this is going to be 1. And then when I divide this, I get exactly 5. So this divided by this is 1. So that's going to be N1. This divided by this is exactly 5. I get C5. So the formula ends up being C5N. So that, ladies and gentlemen, is the empirical formula of this unknown substance, and that's how you solve this problem. I hope this was helpful. If you enjoyed this video, if this was helpful in any way, then please like the video, share the video, hit that like button somewhere over there, subscribe to my channel, and when you do, make sure you click that button, click that notification bell, and when you do, make sure you click all so you'll be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have any problems or questions you need help with, or if you have a topic you want me to cover, I would love to do that for you. Thanks for joining me, and have a great day.